All right, we'll go ahead and get started here. What's up, everybody? Hey, so I told you guys that I would give you guys a short little video talking about the calculations we've talked about so far, about how to calculate both our revolutions, our acceleration, and our velocity here. So I do want to make sure that we can cover those. We covered them a little bit in class today, but just wanted to make sure everyone is down pat with it. All right, so the first thing that I saw a lot of people had problems with was the revolutions, okay? So here's our three equations here. We remember from our handout that I gave you guys that velocity is equal to distance divided by time. Acceleration is equal to velocity divided by time. Revolutions is distance traveled total, okay, divided by the distance covered in one revolution. Okay, and how do we find this distance covered in one revolution? Okay, that's the one thing that we're going to kind of struggle with, and a lot of people have been struggling with. Okay, there's one of two ways that we can do this. Okay, if you guys remember, we talked about way back when placing a mark on our CD here, or whatever our wheel is. Okay, and then we talked about being able to place the mark down on the table, and then roll your wheel until it hits the bottom again. We would measure that distance that it traveled, and that would be the revolution for one wheel. Okay, I'm going to show you guys real quick another way that we could do this that's actually a little bit simpler. And if all you need is a ruler and a calculator, okay, or the calculator on your phone. Okay, many of you guys brought this up, but the circumference of your wheel itself, okay, circumference of the wheel is the exact same as one revolution, okay, and it's actually going to be more accurate as well, okay. So what I'm going to do here is I noticed that the equation for circumference is 2 pi times the radius. Okay, if you guys remember from geometry class, the radius of a circle is the distance from the side to the middle, okay? The difference there is we have what is also known as diameter, which goes all the way across through the middle. All we care about is the distance from the side to the middle here. So I'm going to measure in inches, and I see that my measurement is about 2¼ inches. So I'm going to say 2.25 inches, okay? CD circumference. So I see that my R is 2.25 inches. Okay. So what I need here is I'm going to go ahead and plug this into my big equation up here. So I've got 2, which is just a constant. It's going to be the same every time. Pi, which I'll show you guys on the calculator here in a second, times 2.25. All right, so what I've got here, I'm going to plug this into my calculator. So I got 2, okay, times pi, which is right here, parentheses, 2.25. I get 14.13 inches, okay, 14.13 inches. All right. So some of you guys also, we talked about on Friday, we are given this measurement in inches, all right? Are we likely going to be measuring our total distance traveled in inches? Absolutely not. We're going to be measuring it in feet, okay? Most likely in feet. So what I need to do here is I need to convert this value into feet, not inches. I know that 1 foot is equal to 12 inches. With that in mind, I know that I can get feet by dividing this number right here by 12, okay? So if I take 14.13 divided by 12, I'm going to get I'm going to round here. It's 1.775. I'm just going to round to 1 decimal point to 2 and say that this is 1.2 feet. Okay, 1.2 feet. All right, so that's our measured revolutions or measured distance for 1 revolution. So I've got this part here. Now let's think about our distance. Okay, there's multiple different ways that we're going to have distance here. All right, one of the ones that was brought up in class, the example, was 8 feet 7 inches. All right, so here's distance here. 8 feet 7 inches. All right, what I've seen in some of your guys' work is this, that the distance is 8.7 feet. No, don't do that. Do not do that. That is not correct. Okay, 8.7 feet, absolutely not. All right, how do we convert this though? All right, so we know this is already in feet, so we're totally fine here. However, this portion right here is not in feet, okay? So this is a little over 1/2. All right, so what we need to do is we need to use this same conversion right here to see how many feet this 7 inches is. All right, so what this conversion is going to look like, it's going to be 8 feet plus 7 over 12 feet. All right, you see how I did that? So I basically am taking this guy and I'm going to see how many feet 7 inches is, and I'm going to add it to my original 8 feet. All right, so I plug in 7 divided by 12 into my calculator. I get 0.58 plus 8. All right, so I know that altogether this is 8.58 feet. Okay, so 8.58 feet. So it's not 8.7. It's close to 8.7, but it's not. That's not the answer. All right. So what I did here is I took my 8 feet 7 inches, divided the 7 inches by 12 to see how many feet that was. I get 8 feet plus 7/12 feet. Okay, is equal to, in the calculator, 8.58 feet. Okay, so that's my total distance traveled. So now I've got everything I need to calculate my revolutions here. Okay, so if I come down to the bottom, I calculate revolutions. Okay, see that revolutions is total distance. Okay, 8.58 feet. Divided by measurement for 1 revolution, 1.2 feet. I see that. I make this calculation here, 1.2. I get 7.15 revolutions. Okay, so that means as the car was going, okay, for those 8 feet, it spun 7.15 times. Okay, which makes sense because 1 spin is just a little bit more than 1 foot, and so it's not necessarily going to be 7 feet per revolution, or 1 foot per revolution. It's going to be a little bit more than that. So it does make sense. That should be the right calculation. All right, now let's move on to distance and time, or sorry, velocity and acceleration. All right, one of the times that I was given, okay, I was given time was equal to 2.23 seconds. Okay, time was equal to 2.23 seconds. Well, just with that right there in my distance above, I've got everything I need to calculate everything else. Okay, I've got velocity, so I can go ahead and calculate velocity. which is equal to distance, okay, 8.58 feet, divided by time, which is 2.23 feet, or 2.23 seconds, that is. So if I put this into the calculator, 8.58 divided by 2.23, I'm going to get that I was traveling 3.85 if I go to 2 decimal places, 3.85 feet per second. Okay, that's velocity. Okay, I've gotten velocity. I've gotten revolutions. What's left? Acceleration. Okay, I'm going to move down and I'm going to do acceleration right down here at the very bottom. So I've got acceleration here. I know that acceleration is equal to velocity divided by time. Okay? So I've got velocity here, 3.85 feet per second. And I've got time right here at 2.23 seconds. I plug these guys into the calculator. 3.85 divided by 2.23. I see if I round to 2 decimal places, I'm going to get 1.73. 1.73. So what this is telling me, feet per second squared. What this is telling me is every second, I'm getting 1.73 feet per second faster. Okay, that's how much I'm accelerating. So imagine like whenever you're driving or your parents are driving, whenever they hit the accelerator, that means that you're getting faster every second. Okay, that's what we're calculating right here with this 1.73 value. Okay, so what we did here is we calculated our circumference of our wheel in order to find that out. Okay, we found the circumference by using the circumference equation, 2 pi times the radius, which was from the side of the CD to the middle. We found that it's 1.2 feet. From that, we were able to find our revolutions. We had to find our distance, 8 feet 7 inches. We had to convert because of the fact that 7 inches doesn't work for us. It's not the correct unit that we need. We need feet. So we converted 8 feet plus 7/12. 7 divided by 12 feet. We got 8.58 feet. Okay. We did the same down here with our revolutions, divided by 12. So we came out with 14.43 inches. We got 1.2 feet. Then we just started plugging things into our equations here. We found our revolutions, which is distance traveled, 8.58 feet, divided by 1.2 feet is equal to 7.15 revolutions, which means that the wheel spun 7.15 times as it was traveling. Okay, we were able to find our velocity, which is distance, 8.58, divided by time, which was given to us by our measurement of 2.23 seconds. Okay, we were able to find that, 8.58 divided by 2.23 is 3.85 feet per second. That's how fast the car was traveling. And lastly, we're going to find our acceleration here, which is velocity divided by time. Our velocity, 3.85 feet per second divided by time, 2.23 seconds. We divide those two and we get 1.73 feet per second squared. So every second, whenever we were on that accelerator, where it was starting to move faster and faster, it was moving at a rate of 1.73 feet per second, getting 1.73 feet per second faster each second. Okay, so a lot of cool stuff in here. Hope this helps. If you guys need anything else, let me know and I'll be happy to get back to you guys. Deuces.